All right, now we're going to look at the relationship between vectors and parametric equations and writing vectors as a set of parametric equations and vice versa. So first, let's recall some vector information. So I have this lovely image here, vector OA, vector AP, and vector OP. What's a relationship with them between them? Well, simple vector addition that I know A plus AP equals OP. Okay, that's vector addition. Well, let's get into a formal definition. So suppose P is any point on line AB, then as the diagram at the right suggests, OP equals OA plus TAB, where T is going to be some parameter. This equation is called a vector equation of the line AB, where AB is called a direction vector. All right, vector equation of an object moving with a constant velocity. So I have vector xy equals vector x sub 0 comma y sub 0 plus t times vector AB. This is my rate of change, so this is my slope. This is also the constant velocity. That's why slope is the rate of change. That's the velocity. This represents my position at time t equals 0. So from this, I can write the vector equation as a set of parametric equations. X equals x sub 0 plus at, and y equals y sub 0 plus bt, where a is the change in the x component, and b is the change in the y component in terms of my slope. This is my horizontal change. This is my vertical change. So let's do an example. Suppose an object which is moving with a constant velocity is at point A, 5,3 when time t equals 0, and point B, negative 4,15 when time t equals 3. We want to find the velocity, find the speed of the object, find a vector equation that describes the motion of the object, and write the vector equation as a set of parametric equations. So, first thing you might be asking yourself is, what's the difference between velocity and speed? Besides, in the past, we've said, well, speed is the absolute value of velocity. And that's kind of still true. This is just one of a kind of a weird, unique situation. When we're talking about speed here, we're talking about the average speed. I know I didn't specify that in this particular problem, but for these types of problems, that's what we're referring to when we say speed. So velocity is going to be the rate of change of the vector, which is going to be the slope. That's our constant velocity. Speed, or average speed, is going to be the magnitude of the vector. So what do we need to do first? Great question. Any ideas? Okay. Well, we need to find the vector. So what is vector AB? Well, if I know the 2 points, negative 4 minus 5, comma 15 minus 3, this will be negative 9, 12. The problem is, though, that's after 3 seconds. We need to find the rate of change per second, right? Because whenever we talk about a speed, it's always per a unit time, not per 3 seconds. So what do we do for that? Well, let's make sure we understand what's happening. So in 3 seconds, the object moves this much, negative 9, 12. So it's going left 9 and up 12 within 3 seconds. So what's it doing in 1 second? Well, in 1 second, the object moves 1/3 of that. So that's going to be negative 3, 4. So we can answer part A, where the velocity is negative 3, 4, and we said the speed, remember, is the magnitude. And remember, we find magnitude, negative 3 squared plus 4 squared. So that equals 5. We don't have units here, but these we would have units for velocity or speed, so we could answer in terms of units. Part B. What did part B say? Part B said find a vector equation that describes the motion of the object. So part B, my vector equation is x, y equals, where was the initial point? Well, the initial point was point A, which is 5, 3. So it's going to be 5, comma 3 plus t times my velocity or slope. So notice that this is really essentially just the equation of a line, kind of, but we're using vectors and we have a parameter. But it's like my y equals, this is my mx plus b. So what about part C? So for part C, we wanted to write the vector equation as a set of parametric equations. So I can say x equals 5 plus negative 3t, and y equals 3 plus 4t. There you go. That's my parametric equations. Any questions? Okay, on then. So I want you to try this on your own. A particle moves along a line in the coordinate plane. Its position at t equals 0 is 3, negative 1, and at t equals 2 is 5, 5. Find its velocity, find its average speed, find parametric equations for the coordinates of the particle at time t, and at what point does the particle cross the line 2x minus y equals negative 3? Pause the video. Unpause when you're ready to check. All right, so first label the points. So I called this point A, point B. So vector AB is 5 minus 3, comma 5 minus negative 1, or 2, 6. So its velocity is going to be half of 2, 6 because that was in 2 seconds, right? So I have 2 times V equals 2, 6. So V is 1, 3. Its average speed is going to be the magnitude of the velocity vector. So the square root of 1 squared plus 3 squared. So we get the square root of 10. Find the parametric equations. Parametric equations are going to be x equals 3 plus t and y equals negative 1 plus 3t. And then at what point does the particle cross the line? Well, that's a good question. How do we figure that out? Well, this is the line, right? So do a substitution. So if I know 2x minus y equals negative 3, I can say 2 times 3 plus t, that's my x, minus negative 1 plus 3t equals negative 3. I can solve for t. So the question was, at what point does the particle cross the line? Well, the particle crosses the line when t equals 10. So then if I plug that back into my parametric equations, I can find the point is the point 13, comma 29. So this is where it's important to make sure we understand what is the question asking us for, because here it's easier for us to find the when. So when does it intersect the line first, and then we plug that back into the parametric equations to find the actual point where it crosses the line. Okay, so again, we just wanted to understand our vector equation for an object moving with constant velocity. It's essentially slope-intercept form of a vector with a parameter. This equation can then be split up into a set of parametric equations with parameter t, and speed is the magnitude of the velocity vector. Nice work.